section number 10.6. Section number 10.6 begins on page 745. The key information on section 10.6 is shown at the top of page 745. Let's take a look at page 745 at the very top. In this box, we see three basic scenarios. In the first case, we have two lines that intersect on the circle. In the second case, we have two lines that intersect in the circle. In the third case, we have two lines that intersect outside of the circle. For each of these different situations, we have different laws. If two lines intersect on the circle, the measure of the angle formed, in this case angle 1, is going to be half of the arc whose measure is x. Angle 1 is half of x. If the two lines intersect inside of the circle, the angle formed, in this case angle 1, is going to be x plus y divided by 2. What if the lines intersect outside of the circle? In this case, you're going to take the larger arc, whose measure is x, subtract the smaller arc, whose measure is y, and divide by 2. So again, three different scenarios, lines intersecting on the circle, in the circle, or outside the circle. And notice that their angle measure is, in the first case, half of the arc. In the second case, the sum of the arcs divided by 2. In the third case, the difference of the arcs divided by 2. I would now like to talk a little more about this by using my notes. In the first case, I have a situation where two lines intersect on the circle. So, as was pointed out earlier, the measure of angle 1, this corner right down here, is going to be half of arc n. Problems 3, 12, 13, 14, and 16 all involve this law. Let's take a look at problem number 3. Angle 2 is going to be half of 146 in problem number 3. In problem number 12, angle K is going to be half of 194. Problem 13, the angle in the corner is 72. So the arc PM is going to be double that. The next law we had was dealing with lines that intersect inside of the circle. In that case, the angle labeled 2, angle 2 in this corner, is going to be the sum of the arcs whose measure is n and m, n plus m divided by 2. Or another way of saying that is take the arc AB, this arc right here, add to it the arc CD, divide by 2. Let's take a look at some examples of that. You see that problems 1, 2, 8, 9, 10, and 11 all use this principle. Let's take a look at number 1, page 745. Angle 1 is equal to the measure of BC, which is 86, plus the measure of AD, which is 134, divide by 2. Problem number 2. The arc TS plus the arc QR, which is 108, divided by 2 equals 126. In this case, we'll be solving for the arc TS. Problem number 10. In problem number 10, notice they're asking for the measure of angle JMK. But based on the given information, I will be able to solve for the measure of angle HMJ. So what I'm going to do in this problem is I'm going to find the measure of angle HMJ and then take its supplement to find the measure of angle JMK. I'd now like to move on to the third mathematical statement for this unit. This is a situation where the two lines intersect outside of the circle. The first thing I have pictured here is that the two lines are both secants. The next picture, I have a tangent and a secant. What is a tangent? A tangent is a line that touches a circle at one point. What is a secant? A secant is a line that contains a chord. So I have a secant and I have a tangent, or I have two secants, but the law is the same. To find the measure of the angle in the corner here, angle 3, you're going to take the major arc, subtract the minor arc, and divide by 2. Take the major arc, subtract the minor arc, divide by 2. So angle 3 is equal to the arc whose measure is n, subtract the arc whose measure is m, and divide by 2. Another way of saying that is to take arc AB, subtract arc CD, and divide by 2. The third picture, or the third equation, which goes with this picture here, shows that I'm going to take the major arc, ABC, so that forces you to go around this way. Take arc ABC, goes all the way around here. Subtract arc CD, divide by 2, and that will be the measure of angle 3. So that's when a tangent meets a secant. Let's take a look at a few of these. Let's take a look, for example, at problem number 6. In this case, angle M, which is labeled as 36 degrees, is going to be arc LP minus arc LN. So if I was to set up an equation, I would do it this way. Angle LP, or arc LP, subtract 78, divide by 2, is equal to 36. Another example is problem number 15. Oh, not problem 15, problem number 18. I'm going to take the measure of arc BDC, subtract 99, and divide by 2 to find the measure of angle A. The way I'm going to find the measure of arc BDC is I'm going to take 360, subtract 99, because the total measure of the total angle or circle is 360. So I'll take 360, subtract 99 to find the measure of arc BDC to find angle A. Number 19 works the same way. Number 20, the angle measured 47 is going to equal the major arc JNM minus 111 divided by 2. If I was going to set up an equation, I would set up as follows. X minus 111 divided by 2 equals 47. Problem 22. The measure of angle R is going to be the major arc, SQ, 103. Subtract the minor arc labeled 43 divided by 2. Your assignment for today is all of problems 1 through 28.